Here is an introduction to DataFlow, a family of tools and services that improve research productivity by addressing everyday challenges like metadata capture and standardization, as well as data movement and processing. Here is an overview of everyday challenges overlaid with the typical scientific discovery process in observational sciences. Researchers conduct an experiment which results in potentially large data files. The challenges here are that the storage drives on the instrument computer do fill up, thereby precluding or delaying subsequent experiments. Also, these drives could potentially fail, resulting in loss of all prior measurement data. These files are then copied off the instrument computers using portable storage drives, and this process can take several minutes to hours. Next, data are then typically stored and archived on the researcher's laptop or workstation. Again, these drives here could fill up or fail. Each of these computers sadly becomes a disjoint silo of data. Next, the researcher crams metadata into file paths to make it easier to search for and discover data. As an example, the colored metadata here are not captured in the data files, and not all metadata are captured in general, and each researcher names their files differently, and despite all this, data are still hard to find even for the researcher who created the data. While conducting experiments, researchers also note down contextual information or metadata, such as the intent, experiment parameters, observations, etc., into a physical lab notebook. Unlike data that continue to move, the metadata in the lab notebook is never digitized, transcribed, or married with the raw measurement data. Furthermore, the manner in which these metadata are captured vary dramatically between researchers and even over time for the same researcher. Therefore, these valuable information are limited in both meaning and access to only the researcher who took down the metadata. Next, measurement data are analyzed on the researcher's laptop, and this process could take several minutes to hours due to the limited computational power of the laptop or workstation. The analysis results in ideas for the next set of experiments, and this process continues iteratively. The thing to note here, though, is that it takes considerable time between one set of experiments to the next due to the suboptimal and ad hoc practices. DataFlow is aimed at providing solutions to such everyday problems that dramatically reduce the productivity of researchers. The current iteration of DataFlow provides a simple web interface which can be made available even to instruments that are disconnected from the network, where both ORNL staff and visiting researchers can log in, capture rich metadata regarding their experiment, and then drag and drop relevant data files. DataFlow would then upload both the data and the metadata to a centralized repository, which will then allow users to make use of high performance or cloud computing to analyze data, scientific data management systems to manage the data, or use high performance networks to move and share data with other researchers. DataFlow can be accessed via https://dataflow.ornl.gov. The welcome screen provides a brief description about DataFlow. You can find more information about DataFlow by either clicking on the help link on the top right of the page or on the documentation button at the bottom of this welcome page. We start using DataFlow by clicking on the Login Now button. We will then be asked to authenticate ourselves, first with our organization, in our case Oak Ridge National Lab. ORNL staff and postdocs will need to authenticate with their UCAMS account, while visiting researchers will need to use their XCAMS username and password. We will then be dropped into the DataFlow interface, which will immediately ask us to activate or reactivate the Globus endpoints necessary to transfer data using our XCAMS or UCAMS credentials. We can now click on the New Dataset button to begin the process of capturing metadata and then uploading raw data. First, we provide a title for this dataset. If relevant, we can choose an instrument from the drop-down menu, like Citation 5, to get standardized metadata fields for this instrument. If not, we can leave the instrument as none. We can click on the Add Additional Metadata link to record relevant experiment parameters that we may want to search on in the future, such as temperature and pressure. We can add any number of these fields, and once we're happy, we can click on the Next button. We are then shown a different panel describing the dataset with the title, creator, instrument, and the metadata. We can now drag and drop files or folders into this window to upload them. Alternatively, we could click on the Upload Files button to select one or more files to upload, The interface then shows a blue progress bar to indicate the progress in uploading the selected file. Scrolling below reveals the names and sizes of the files and folders that have been uploaded. One convenient way to access the data and metadata that have been uploaded is the Globus web interface. So we can go to www.globus.org and then click on Login, then authenticate our institution as Oak Ridge National Lab, and then ourselves via our UCAM's credentials. Once we're dropped into the Globus web app, we can click on the search in the collection bar, then find CADE's OR endpoint, and selecting that reveals the contents of the user home directory in CADE's. Scrolling below, we get to the directory called DataFlow. Since we didn't choose an instrument, we open the directory called Untitled_instrument, then the directory with today's date, and finally the directory with the appropriate timestamp and title that we gave to the dataset. Inside this directory, we'll find a screenshot data file that was uploaded along with another metadata.json file that contains the experiment parameters such as the temperature and pressure that we entered earlier into the web interface. As we've seen in the demo, DataFlow provides users with a simple web interface to upload data and metadata to a centralized repository. By moving data from the instrument computer or researchers' computers to safer and scalable storage, researchers need not worry about storage drives failing or getting filled up. Standardized metadata forms per instrument or even modality can ensure that all relevant metadata are captured and captured in a standardized manner across all researchers. We can deploy DataFit software on a server in close proximity to one or more instruments that are off the network to bring the same capabilities to these instruments. This removes the need for USB drives to transfer data from instruments and allows researchers to upload data to their own secure storage space. Such a facility local server is also ideal when there's a need to upload data from instruments that generate large volumes of data quite rapidly or regularly as fast as possible to a centralized repository. Now that DataFlow uploads data and metadata to a centralized repository that is co-located with other data services and compute resources, this opens doors to several applications. While researchers can set up downstream applications themselves, we plan on integrating some of the following more popular capabilities directly into DataFlow. As an example, we plan on adding the option to upload and marry data and metadata to a scientific data management system like DataFed to make it easier to organize, search for, and share data. This way, researchers don't need to cram metadata into file names and spend lots of time searching for their own data or sharing with other collaborators. There are several videos on DataFed available on YouTube if you want to learn more about DataFed. Workflows could be set up to automatically analyze data or run simulations using high-performance computing resources the moment data are uploaded using DataFlow. Results from these simulations and data analyses could be piped directly into DataFed as well. This would provide insights regarding the experiments sooner to researchers, thereby allowing them to maximize their time on the instrument. Additionally, facilities could choose to run their own data analytics platform like a Jupyter Hub that could make use of the uploaded data from DataFlow. Such data analytics services like the Jupyter Hub and DataFed could also be accessed at off-network instruments using the facility local server. In the future, we plan on integrating with DataFed to provide comprehensive data management, automating pre-processing such as metadata extraction or format standardization on the facility local server before the data is uploaded, automatically triggering large processing jobs once data is uploaded via DataFlow, providing a programming interface in place of the web interface to upload data from instruments without the need for a human user, and several other management capabilities. If you have any questions or need additional information, please feel free to contact me.